question number 61, which is a very important one, which says that which compound contains maximum number of peroxide bond. So first of all, tell me what do you mean by peroxide bond. अगर ऐसा linkage हो O, so this is known as the peroxide bond. So now among the following four compounds, find out the number of peroxide bonds. So for this you need to know the structures of all the four compounds. So in the first case we have K3CrO8, which has little bit complex structure. So in this case we have this kind of structure. So in this case you can see here there are four peroxide bonds. There are four peroxide bonds. And now draw the structure for CrO5. So in the case of CrO5, you have a butterfly kind of structure. So in this case we have two peroxide bonds. And now you have H2SO8, which is also known as the Marshall's acid. So in this case you can see here it has one peroxide bond. So now you have H2SO5, which is known as the Carr's acid. So it also has one peroxide bond. So maximum number of peroxide bonds are present in K3CrO8. So option number 1 will be the correct answer. So moving on to the next one, we have question number 62, which says that choose the correct statement. So this is all fact based. In the first one we have butter of tin. So the formula for butter of tin is SnCl4.5H2O. So this is absolutely correct. In the second statement we have carborundum. So carborundum is the silicon carbide, that is SiC, not aluminium carbide. So this is the wrong option. Now we have the third, in which we have corundum. Corundum is the Al2O3, that is correct. So now we have the cardice, and which is CO2 solid. So this is also known as the dry ice. So this is also correct. So now we have the first, third and fourth are the correct options. So it means option number 2 is the correct answer. So now moving on to the next one, we have question number 63. So in this case we have to identify the equivalent weight of Cl2 in the following reaction. So we have this reaction in which Cl2 is reacting with OH negative, forming Cl negative and OCl negative plus water. So here you can see that in the reactant Cl has the 0 oxidation state, and in the product we have Cl is in -1 oxidation state and in +1 oxidation state as well. So the chlorine is being oxidized and as well as reduced. So this is an example of the disproportionation reaction. So to calculate the equivalent weight in the case of disproportionation reaction, first of all write oxidation reaction and reduction reaction separately. So first we will write the oxidation part. So this is OCl negative So यहाँ पे है oxidation state 0 and here it is +1. So first balance the chlorine atom. So here it will be 2 OCl negative and here 2 electron. So this is the oxidation. So now write the reduction part. So balance the chlorine atoms and here also 2 electrons. So ये हो गया reduction reaction. So in the disproportionation reaction, the equivalent weight of chlorine will be the sum of equivalent weight in the case of oxidation plus in the case of reduction. So in the case of oxidation it will be m by 2. M is the molar mass of Cl2 and N factor is 2, plus in the case of reduction, so it is also m by 2. So here it will be m. I hope this is clear to you. So now option number 2 is the correct answer. So moving on to the next one, we have question number 64, which says that which of the following compounds don't undergo hydrolysis. So you have 4 chlorides with you, that is silicon tetrachloride, carbon tetrachloride, thallium trichloride and boron trichloride. So the first and foremost condition of the hydrolysis is that it should have the vacant low-lying d orbitals present so that the incoming water molecule can enter into the vacant orbitals. So अगर हम देखें, we have the silicon tetrachloride, we have vacant orbitals present in the silicon, so it can undergo hydrolysis very easily. So now if I talk about CCl4, so you very well know that the carbon does not have vacant low-lying 3d orbitals, so it is very inert towards the hydrolysis. It don't undergo hydrolysis. So option number 2 will be the correct answer. So option number 2 will be the correct answer. So moving on to the next one, so we have question number 65. So in which we have a series of reactions and we have to identify the correct options on the basis of the reactions given. So in this case you can see here, in the first reaction X is reacting with lithium aluminium hydride and giving a hydride Y with other compounds, and Y is further reacting in presence of air to give B2O3, which is the boron anhydride plus water. So यहाँ पे the compound is of boron, that is boron anhydride, which is formed from Y. So we can say that कि Y will be a compound of boron. अब हमें यहाँ पे given है that Y is a hydride. So आपको पता है कि boron कौन सा hydride बनाता है, that is B2H6. So we can say that Y can be B2H6, and it is one of the famous reaction for the preparation of B2H6 when BCl3, that is boron trichloride, is reacting with lithium aluminium hydride. So it gives B2H6. So this is the Y compound and this will be the X compound. Fine. So now we have identified both the compounds X and Y. Now consider the following statements related to X and Y. So in the first case we have been given that X behaves as Lewis acids. So ऐसे कौन से compounds हैं जो Lewis acids की तरह behave करते हैं? तो compounds which are electron deficient, they behave as a Lewis acid because they are electron acceptor. So we know that in the case of boron trichloride, it is an electron deficient molecule. So this can act as the Lewis acid. So now we have the Y behaves as Lewis acid. So it is also a compound of boron. अगर ये dimer भी बनाता है B2H6, still it is an electron deficient compound. So we can say that it can behave as a Lewis acid. So this is the correct statement. Now we have in the third statement, that is hybridization of central atom in X and Y are sp2 and sp3 respectively. अगर हम BCl3 का structure draw करते हैं, so it has a trigonal planar structure. So you can see here it has 3 sigma bonds and plus 0 lone pair. So hybridization कितनी हो जाएगी? It will be sp2. So now if I draw the structure for B2H6, that is the dimer. So this is the structure for B2H6. So in this case you can see here each boron atom is forming how many bonds? 4 sigma bonds. So hybridization will be sp3. So we have third statement also absolutely correct. Now we have the Y contain 3-centered 2-electron bonds. So B2H is a very famous example where the 3-centered 2-electron bonds are present. So you can see here there are only 2 electrons, but there are 3 centers, that is 2 boron and 1 hydrogen, and they are also known as bridged bonds or the banana bonds. Bridged or the banana bonds. So this is absolutely correct. So we have all statements that are correct. So option number 4 will be the correct answer. So moving on to the next one.